So this is the chi-squared test. The chi-squared test is a test to measure the size of the difference between the results to get the results that to find out what results you should be getting. So you find the probability of the difference due to being chance alone. This is from the observed results from a genetic cross, so this is from genetics. But the genetic cross will always differ just by chance. But the more repetitions that you do for the experiment, with the greater numbers of data, there will likely be more accurate data, as it reduces the probability of skewed data. So the more repeats you do, the more likely it is you're going to get reliable data, and you're going to notice the odd ones, the anomalous points. So this is the chi-squared formula. So this is x squared equals the sum of, and then this looks a bit complicated, but you're going to be given all the information in the question. So these are the observed frequencies. So this is O, and then you minus E. So it's the observed frequencies minus the expected frequencies, and then you square that, then divided by the overall expected frequencies. And then once you've got the number for this, remember that here it is squared. That means you need to square root the answer to get the probability. So larger chi-squared values is a statistically significant difference between observed and expected results, and the probability that these differences are due to chance is low. There must be a reason other than chance for the unexpected results. So the degrees of freedom is the number of the comparisons being made, and is calculated as n-1, when n is the number of categories. So once you've got your number here for chi-squared, you would then have to calculate the degrees of freedom. So say you have yellow and green peas. So you have yellow peas and green peas and orange peas. So this is you have a little table with numbers in. This here means that there's 1, 2, 3. You have 3 categories. So remember, to get the degrees of freedom is n-1. So you have 3 categories, or however many categories you've got. So here you've got 3 different categories. That would mean you do 3 minus 1 is 2. And it's this 2 is the amount of degrees of freedom. So if the calculated chi-square value is greater than the critical value, so you get this table. Once you've got the table, you go to see down the left hand corner there's degrees of freedom. So here you can see the degrees of freedom is 2. So we look for 2 here, and then we go across, and then with the chi-squared value, say it is, you always look for here 0.05. This is the key cut-off point, 0.05. So you've got your degrees of freedom, which in this case is 2, because you've taken the number of groups away from 1. And then whatever number you have, if it is past the, if the calculated chi-square value is greater than the critical value, so this is the critical value here, so critical value, and that's 0.05, that's critical value. If the calculated chi-square value is greater than the critical value found as 0.05, or that's actually 5%, you can accept the null hypothesis. That means that it's only due to chance. However, if it's less than 0.05, that means it's less than 95% accurate, the null hypothesis can be rejected. Another factor is causing a difference between expectation and observation. The critical value of 5% increases as the degrees of freedom increase. So the critical value is extremely important. And then, so as it gets bigger, it has to be here or afterwards. It can't be before, because that means that there's a greater likelihood of